Maybe put it back here or somewhere. No, like here. Here there's some space.
Do you want to move these other things?
Oh, that's okay. I'm trying to figure. Okay, song.
Okay.
All right.
Okay, I already told you about the files, that it's possible to access the computer over there in order to download your files. So if you type in from any computer, which is in the network, I guess, but especially this, because this is the one we left, you can type in 192.168.140.7.3000. That's the address of the computer. It's in here already. So, and then we have files over here, and then here are a lot of STD and SCN files, and then you can download them by just maybe it's test Jan, it's over here, and then here are our files, and then you just can download them. And if you press upload file,
Put it back.
let's just browse, and then you can browse them, like upload any file.
This computer is connected to that computer on the outside?
Yeah, this computer is connected to outside, to all of the, actually to all of the components. It's
Yes, but we have to work differently.
there's a central computer.
Right.
Maybe I have a picture on instructions.
There's a computer.
So there we have several computers, and I think there's a picture in here showing the communications. Here. So this is the office laptop.
Oh,
Can I get that? We are right off this office. So, and this is also to Concordia. So this is on the internet as well. So, and by this one we can access the central control system. And then we have some CAN communications. CAN is the protocol, like it's a bus system. But we have also connection to the collector test platform with Ethernet. So there's a data acquisition unit on the collector test platform, and some controllers.
So efficiency.
So it can also access the mobile lamp field. The Atlas cabinet here is also by Ethernet. So that's how the communications
no, it's some
work basically.
No, it's efficiency. It's efficiency formula.
Maybe it's connected as well, but I have
That's the
That's how much energy it produces. They are
Of our
still
own
meters.
that's of your
sensors.
national.
Only airport.
And this is a temperature.
Outside, no. This temperature outside. And this is how much produced outside. And this is
Okay.
together both sun and air. This is just air. Sun and air. Hydraulic pressure.
I close. Okay. If there should be one time that you need an update or something like that, there's a software
We just
update log, and it's also we send you a software update for the central control system, you can upload that over that. But it's also
Well, not on this
possible.
one,
There's a program here
It's on the server
called
itself.
PuTTY.
Just basically
Yes,
how to-
Concordia update, and you can run that, and then you give us access to the computer. That's what I did the last 2 days. And then we will tell you how to proceed with that program.
to mount
Okay?
and connect it.
Okay, so
The way it-
what I don't know
on
is
the angle thing.
I have here my own LabVIEW program, which I left the last time over here.
Does the air one.
Here's a folder, LabVIEW Yan. There's also LabVIEW programs by PSE.
Well,
This is not working like it should.
It's the ones
I don't know
like the
if
phone, yeah.
somebody has already
This is-
changed
this is
some
the air.
things for
We need to
improving
like
that.
this, make them
I will show you the program
Yes.
we left over here because that's working.
Yeah, because you have a
Okay.
back. No, it's not here, sorry. But we'll
That's okay. Here, figure out.
That's Concordia Airco for air collector, water collector final version. And
Oh, prospects here.
this is how it looks like. You can rather decide if you want to test a water collector or an air collector just by pressing on that. If you test
Yeah.
We'll do air collector or this afternoon.
Good is.
I would just start the program by pressing on the right here. This is open. You can change everything, whatever you want with the program, add new sensors or things like that.
What if it's collector like this one, which has both water and air?
This is not foreseen so far, but in principle it would work. I would just go for air testing. Because all the sensors are connected then, water sensors and air sensors. And then I would just run the test. The only thing which is not done then, if you test the air collector, no. I will go first through, and then we talk about first water, and then 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 air water. Okay. Okay. For start, just press the start button, the run button. Most of you might be familiar with that. So this thing directly connects to the data acquisition system, which is on the collector test platform. As I told you yesterday, it is possible that the central control computer is also connected to the data acquisition system. This will say here Agilent logged by external process. If the other computer is locking this one, it will indicate that the data acquisition unit is locked by something else. And then the program will not start. Okay, what you can set here is the interval for taking data. So at the moment, every 5 seconds we collect new data. And the same is that's Vago, that's the controller we use for controlling the speed of the pump and for controlling the temperature of the temperature control unit for the set values. So this is giving a 0 to 10 volt signal for setting the frequency of the pump and also for the temperature of the collector. Okay, what I already told is that over there the temperature control unit just starts right away, right on a 20 degree temperature level. Here's a button saying temperature control of thermostat by a LabVIEW. You just press that, and now this program has the control on the temperature control unit. What you could do is before you start the program, change the path of where your data is saved. It will always save the data in a just regular file without anything. Always with the date of the current date. So 2013, 11, 14. That's the 14th of November. So this is the data how it is saved here.
Yeah, no, I'm not really.
Okay. Then maybe we go first to the temperatures. No, maybe we. So what we can see already, the inlet of the collector is at the moment at 22.84. Outlet is 43, mass flow is 45, ambient is 22. Ventilation is ventilation left is the left one of the ventilation system, the right one is 21. And the cooling water, which is going to the temperature control unit, is at 10 degrees C. We just save that value in order to see if there's a problem with the machine or something, it's not running anymore, in order to check if the temperature, maybe the water of the cooling water was not switched on. That's just for a controlling value. So here you can always see the current power output of the collector. What is the power output? Calculated by the mass flow, the specific heating capacity of the water, the temperature level, by the mean temperature in the collector. But you see, it's dropping at the moment because we increased the mass flow, so the power is getting lower. Okay, temperatures. It's not so important that the irradiance is not displayed because we will take the data from the scan anyway. But I will check why this is not. Maybe they changed. This is the old version of mine. Maybe they changed the channel of the pyranometer. So I will check that. As long as it's working with the other thing, that's fine. What we see, we don't have any wind speed. Before we start the scan, we forgot to put down the wind sensor. For the test now, it's also not so important because we will scan after the test. But yeah, we should before we start the scan, we have to put down the wind sensor. Well, we see that the controller over here, that the controller is now controlling the water to 144 kilograms. What is the aperture area of your collector? 2 square meters?
Yes,
2 square meters.
It's 1 by 2.
Okay, so the standard is saying we need a mass flow of 0.022 kilogram per hour per square meter. Okay, if we have a 2 square meter collector, that means 144 kilograms per hour. So maybe going back now a bit, I set the inlet temperature. At the moment we are at manual control, we call that. We set the temperature at 20 degrees C and 144 kilograms per hour. What I already mentioned yesterday is that for an entire collector test, we need. Maybe I get my computer and we can visualize that a bit more.
All right, we
are, so I can get out. It looks like we're doing it a radius.
No, I don't think. I think that they give it.
Or actually just, oh, right.
Because it takes a long time to scan it. I can just go from one. Yeah, so the data actually is just an email away. It just doesn't have its own computer yet. We're trying to get that trace and then get it like so we can get access to students manually.
20 different things, right? And so we're gonna have
Go over there, switch the data acquisition off of the central control system, go back, try to connect again, then it should work.
all these things. You know, they need to be tested.
Computer broke yesterday.
Is it complicated to modify this program for another test setup? I guess it's
Not for me. If you have any experience with LabVIEW, it's not complicated. If not, it will take maybe a week or something, or I don't know. It's a bit depending on how skilled you are with programming.
I mean, is it complicated to navigate what is there? Is it easy to understand?
I can show you something. That's not perfect.
Nikon.
I don't even understand.
You have to change based on the function system. Begin like
Oh,
step by step, see that you have to change.
You know what? Here's the thing. Don't put maybe in brackets. Okay, I should be listening.
It's just too crowded here now.
You got ventilation? Yeah.
Okay.
You're gonna give us this, right? Or give me this and
I give you that.
yeah.
So, what I already said yesterday, what the standard tells you is to go to a certain temperature level, wait for 15 minutes, and then wait for another 10 minutes, right? So this is what you can put in here. That's for timetable. Put 15, tell the computer to wait for 15 minutes, then wait for 10 minutes, 10 minutes, 10 minutes, 10 minutes. And while he's doing that, he's doing 20 degree, 144. When he's once gone all through that, he's going to the next level, 40 degrees C, also 144 kilograms, because the temperature changes, but not the mass flow. And the mass flow will change by the temperature, but the controller will always control it that it will stay at a certain level of 144 kilogram per hour. So this thing over here is the accuracy which is allowed, and this is, I call a threshold. It could occur that you have a lot of heat losses because the temperature control unit is controlling the temperature in the water fluid close to the heat exchanger. It could occur that you have, like, I don't know, heat loss of 2 Kelvin till the inlet of the collector. So if you would type in 0 over here, it would have no tolerance. So what I always do is type in something like 4, 5 or 6, or something like that. To let it vary.
window.
It does not matter if you are at 40, 39, 38, or if you are 42 degrees C. It does not matter at all. So give him a little bit a gap, and it will also. Actually, it's not a. It's just controlled. The signal over there is just controlled by a 0 to 10 volt signal. So to set the temperature. So if you might set here 20 degree, it will be